So we have a little bit about the definition of equilibrium. We should be able to write equilibrium constants. Recognizing that we did a couple of exercises in the lecture notes where we reversed the equation and then changed the coefficients, so something about that's probably coming. Then we made a note that the magnitude of the equilibrium constant gave us some information. I will be seeing if you know how to interpret the magnitude of the equilibrium constant. Then we proceeded to calculate equilibrium constants from equilibrium concentrations. Should be pretty easy, plug numbers in, away you go. Note that problem could be done forwards. Here the equilibrium constants, what's the value, equilibrium concentration, what's the equilibrium constant? Or could we work backwards if I give you the equilibrium constant and some information about the concentrations, what's the missing piece? Then we worked problems with ice tables. We did all reactants, then we did all products, then we did some reactants, some products. We saw the quadratic equation. The formula for the quadratic equation is given on the quiz in the header part. And you can use your calculator if you were smart. From there, we talked about Le Chatelier's principle. So there's several different scenarios where you can change concentrations and then see how the reaction is going to shift, and then calculate the new equilibrium concentrations. So there's some qualitative stuff, which set of conditions would cause the reaction to shift left, which one should shift right, what would happen if you added, what would be the result of, those kind of questions are in there, and then a little bit of math, possibly with a modified ice table. Then we talked about changes in the equilibrium constant at the end of that Le Chatelier's principle discussion, where we had that complicated equation with Ln of K2 over K1 is equal to delta H over R times 1 over T2 minus 1 over T1. So you've got some stuff in there that you can work with. Recognize it's very similar to the kinetics equation, so you might think about how the equation actually works, maybe what would the graphs look like if I had to graph. And just really focus on what is the meaning of the equation as much as the calculation. At that point, I think I've hit the whole chapter. You do have PowerPoint slides for everything I just mentioned. You probably have OWL problems that are extra. Recognize if you use the lecture notes and you get rid of the OWL problems that are not in the lecture notes, then you have homework problems that you can practice each one of those things.